Hello, sixth graders. Today we are going to talk a little bit about terminating, meaning ending, and repeating decimals. What do we do in those situations? Before we get started on that, I would like to revisit rational numbers. So take a look at this chart right here. Okay, and here, let me switch colors. Here, we see the diagram where it says rational numbers. And notice that all integers, all whole numbers, all natural numbers are considered rational. So just to get our brain around what rational numbers are, let's think for a minute about what irrational numbers are. Irrational numbers are numbers that have no end, meaning you could spend your whole life doing a division problem to figure it out what the last digit of that decimal number version would be and never find the end. For instance, we know that pi is a number that has no end. Let's take a look at this for a second. Notice this was published on March 15th, guys. There is now a U.S. computer storage company that has used their computer to calculate the first 105 trillion digits of pi, which is a world record. The calculations took 75 days and used up 1 million gigabytes of data. Whoa. We could consider trying to find the end of pi pretty irrational because, as we know, if your grandmother worked on calculating the digits of pi her entire life, and then your mother picked up from where she left off, and then now you spent all of your days calculating the digits of pi, none of you would ever find the end. So it seems pretty irrational to me. All right? Rational numbers always have an end or a repeating decimal, meaning at some point there's a pattern to the numbers, which means you can always predict what the umpteenth digit of that number would be because there's a pattern, making, even though it also has no end, it has some rationality because you don't have to keep calculating. Okay? So if we're looking at the lesson, what might we learn about terminating and repeating decimals today? Well, we're going to learn how to use bar notation. And you'll find out more about that very soon if you don't already know. And you'll also learn how to find a repeating pattern. How to find a repeating pattern. Okay, so let's take a look at all of that. Here we go. So we are learning today that any number that can be written as a fraction is called rational. Any number that can be written as a fraction is rational. Remember, we said up here that whole numbers are rational, right? So can we write that as a fraction? Absolutely. The whole number 6, just put it over 1 because 6 divided by 1 is 6. So it doesn't change anything to write that as a fraction. We've also learned that every rational number can be written as either a terminating decimal or a repeating decimal. So what are those things? Let's see here. The decimal form of a rational number, 0.333333, ... meaning the threes keep going. That would be repeating, right? Okay. So then a terminating decimal would mean the decimal form of a rational number, which has a repeating digit of 0. Okay. So meaning it ends, right? 0.625 and we're done. We could then repeat 0 as many times as we want at the end of that, but it terminates or ends. Let's take a look at this real world link. Jude is buying fruit snacks for party favors. He asked the cashier for a ½ pound of fruit snacks. Express 1/2 as a fraction. Okay, got it. 1/2. All right? And then it says write the decimal that represents ½ pound. Well, that's something we've learned already. 0 and 5/10 means 1/2. Suppose Jude wanted to buy 1/3 of a pound. What decimal would the scale show? Well, that's interesting because 1/3, when you calculate it out, let's just do that really quick. Doesn't go into one. Okay, so let's see here. 3 goes into 10, 3 times 9, subtract 1, bring down a 0. Wait, that's 10 again. So 3 goes into 10, 3 times 9. Is this just going to keep going like this? The answer is yes. So it would be 3, it would be 0.3333 dot, 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 because it just keeps going. And that's where bar notation comes in, because we could write this as 3 and put this bar over the top of those 3's, and that means it's a repeating decimal. So you put a bar over the pattern, okay? Let's see here. FYI, I've put this in here, right here. It is common fractions and their decimal equivalents. You should also have those in your math notes. If you don't, come ask me for one. And eventually, it will make your life so much easier if you just commit them to memory. Ones that for sure you should really, really know. 1/3 is 33333. 1/4, that's 4 quarters in a dollar, right? Okay. 9/10, I would say that one's pretty important. And if you know 1/4, you also know 3/4 and 1/2. 1/10 is incredibly valuable. So if you don't memorize them all, at least know that's 1, 2, 3, 4, 5, 6. You will use them countless times throughout life. It's good to know them. It will save you some stress of having to figure it out or go find it on the internet or however it is you do that, okay? So rational numbers can be written as fractions. In algebra, we would say A over B, and B does not equal 0. So you would never do this, 6 over 0. Okay, that just doesn't make sense. How can I have 0 groups if I have 6 things? I can't make a group of 0 out of 6. It doesn't make sense, okay? So I'm reading right here. Fractions, terminating and repeating decimals, percents, and integers are all rational numbers. Every rational number can be expressed as a decimal by dividing the numerator by the denominator. And remember, numerator is on top, denominator is on bottom of our fraction. So numerator divided by denominator, right? Okay, so and here's a smaller version of what I put onto the side there. All right, except for that 3/10 isn't a common fraction, so you won't see that over there. All right, to indicate the number pattern that repeats indefinitely, use bar notation. For instance, look at this pattern right here. We have 5, 4, 5, 4, 5, 4. So there's our repeating. So they put a line over 5, 4 and call it good. Same here. 5, 8 doesn't repeat, but then we have 3, 3, 3, 3, 3. So there's a line over just the 3, the bar over just the 3. So here's an example, right? 5/12 is a decimal. Okay, so it's 5 divided by 12, and you get 4166, and the 6 is repeating, so they put the bar notation over the 6. Okay, let's try some. All right, 1/6. Is that on our chart up here? No, we're going to have to do the work. So that would be 6 divided by 1. 1 goes into 6 times. Oh, I just did that wrong. So if you got that before, you can't have a hawk feather for that because I just caught it myself. Miss Mannion, boy. 1 divided by 6. Numerator divided by denominator. Can't go 6 into 1. So we'll just add a decimal. Okay, 6 goes into 10. 1's 6. Subtract 4, bring down a 0. 0, many times is 6? Well, I know that 6 times 7 is 42, so it must be 6. 6 times 6 is 36. 40, take away 36 is 4. There's our repeating decimal. Right, guys? Because I had 40, now I have 40 again. It's just going to keep going around and around. So I will write A as no holes and 16 hundredths, but I'm going to put that bar notation over the 6 to indicate that it goes on and on and on. 8/9, is it on our chart? Nope. Okay, so let's do the work. Let's get it right this time, Miss Munyon. 8 divided by 9. Doesn't go at that. 9 times 9 is 81. So this must be 8. What's 8 times 9, guys? That would be 72. 80 minus 72 is 8. Bring down a 0. 9. Oh, it's already repeating. Whew, I thought I was going to have to work. Not today, folks. All right, so bar notation over the 8, indicating that the 8 repeats. So now we have 2 11ths. 2 divided by 11. I'm going to switch colors here. 11 goes into 2? Nope. Okay, so 11 goes into 20 once. 11, 20, take away 11 is 9. Bring down a 0. 11 into 90, that's going to be 8. 8 times 11 is 88. Subtract 2. 90 take away 88 is 2. Okay, bring down another 0. 11 into 20. Oh, didn't we start with 20? I think I see our pattern. So 11 goes into 20 once. 11, subtract 9, bring down a 0. Yes, so here is our repeating pattern, 18. So I will write that as 0 and 18 hundredths with the bar over the 18 to indicate that that will repeat itself. Oh, I'm liking this. It's like I don't have to finish the math problem. Of course, I couldn't even if I tried. Let's move on. Here's another example. It says write negative 2/9 as a decimal, but when they go to do 2 divided by 9, it repeats, right? So they're going to write it as negative 0.2 repeating, okay? And another negative 2 and 2/3 as a decimal. So look here, this part is right here and right here. The negative 2 is before the decimal. So when we do the math, we just do this part, 2 divided by 3. And I do believe actually that that is up here, 2/3. Yeah, right here. 2/3 is 0.6 repeating. Is that what they got as well? Yeah. So we're going to write negative 2 and 6/10 repeating. Okay? And we're done. Let me get rid of that because that's for A. Oh, 1/4. That is a common fraction, isn't it, guys? So 1/4, there's 1/4 in a dollar, so that's 0.25. And if you don't remember that, it's up here, 1/4. Okay? All right. And we could put a 0 there, and it's negative, right? So negative 0 wholes and 25 hundredths. 5, 6. I don't believe that one is up there. There might be 1, 6. Let's take a look. Nope, no 5, 6. So let's do the work. Okay, so that's 5 divided by 6. Doesn't go. 6 times 8 is 48. Make my decimal a little bit bigger. 8, 48, 50. Take away 48 is 2. Bring down a 0. 6 goes into 20. Well, 6 times 3 is 18. 6 times 4 is 24. 3. 6 times 3 is 18. 20, take away 18 is 2. Oh, we got 20, and then we got 20 again. So we have a repeating decimal right here. Okay, so we're going to write 0. Oh, it's negative again. See that? Negative 0 and 83 hundredths, but the 3 is repeating. Okay? Now we have F, negative. I'm just going to put my negative over there right now so that I don't forget. Negative. Okay? 2 and 1/6. Is 1/6 a common fraction? Nope. Okay, so let's do the work. Okay, so that's 1 divided by 6. Okay, 6 goes into 1, nada. Okay, 6 goes into 10, 1 times 6. 10 minus 6 is 4. Bring down a 0. 40. 6 times 7 is 42. 6 times 6 is 36. 36. 4. 40 take away 36 is 4, right? 36, 37, 38, 39, 40, yep. Oh, 4, when I bring down the 0, I have 40 again. So I know that 5 is going to be a repeating, 6, is going to be a repeating decimal. Forget that. Well, actually, it wasn't. Okay, so 0.16 or 1600ths, negative 0 and 1600ths with the 6 repeating. Cool. Okay. Go a little slower, Miss Manion. Ooh, calculator time. I can't believe they're letting us use a calculator. So it says Frankie here made 34 out of 44 shots. 34 out of 44 in all. Okay? To the nearest thousandth, what is his free throw average? So if we were to do that on a calculator, we would do 34 divided by 44 equals. And look, here's our repeating pattern right here. 2, 7, 2, 7, 2, 7, 2, 7. So I'm going to take up 7, 7, 2, 7. I'm going to take that back over here. So it's 0.7727 repeating. And they want to know his average to the nearest thousand. So that's tenths, hundredths, thousandths. So I'm looking at this number right here. 7 is 5 or higher, right? So greater than or equal to 5. So I'm going to round this number up. So that will be 0.773, right? Okay, let's try another one like that. And you may use a calculator. Of 9 students surveyed, 4 said they prefer exercising. So 4 out of 9 prefer exercising. Let's try that one on a calculator. Okay, let me clear mine. 4 divided by 9 equals, 4, 4, 4, 4, 4, 4, 4. So it's 0.4 repeating. What do they want us to round to? 0.4 repeating. And it says express the fraction as a decimal. Oh, it just says use bar notation. So we would actually just do 0 and 4/10 repeating. Okay, let's try some of these. I'm going to look, are any of these common fractions? Any at all? 7 9s, 1/33, 5 6, 4/5. Let's take a look. 4/5, no. 1/5. I don't see any so far. 5 6, 5 9s, 10. No, I'm not seeing any, but one might show up. All right, I'm going to erase this right here so that I have room and my space over here. If you guys run out of room, you do know that you can just get a sheet of paper, right? And staple it to the back when you're done. Or use your whiteboard. Okay, so 7 9s as a fraction. 7 divided by 9. Numerator divided by denominator. 9 does not. Oh, how did that happen? 7. 0. Put my decimal up. I'm going to switch colors here. 9 goes in. 9 times 7 is 63. So 9 times 8 is 72. 8's too high. Let's use 7. 370, take away 63 is 7. Bring down a 0. Oh, wait. I did into 70. Now I have 70 again. That's repeating. So 0 and 7/10 repeating. Okay? Let's try number 2. That's going to be 1 divided by 33. Ooh, and it's negative. I'm going to put my negative symbol there right now so I don't forget. Okay, switch colors. 33 into, that doesn't go. But I need a 0 because I can't just leave that space blank, right? Add another 0. 33 into 100, that would be 3. 3 times 33 is 99. Subtract 100 minus 99 is 1. Bring down another 0. Oh, look, I started with 10. I'm at 10 again. It's going to be 0.0. Does the 0 repeat, guys? No, just this. This is the repeating part. So that's going to be negative 0 and 3/100 repeating. All right, let's try another one. We have negative. I'm going to put my negative symbol there right now. 2, that's a whole number. I'm just going to add that as well. So 2 and 5, 6. 5 divided by 6. Switch colors. Doesn't go. 6 into 50. Well, 6 times 8 is 48. Let's use that. 8. 6 times 8 is 48. Subtract 50, take away 48 is 2. Bring down a 0. 6 into 20, 6 times 6, 12, 18. That'd be 3. 18, 20, take away 18 is 2. Oh, a 2. Look, when I bring down the 0, I'm going to have 20 again. So there is my repeating decimal, right? So, and that's 2 and 83 hundredths with the 3 being a repeating decimal. We're not going to get the 8 again, are we? Because 20, when we do the 18, that'll be 2 again. No. Okay. Let's try this one now. 10/15. I thought about, could I just multiply to get hundredths? But I can't because 15, it doesn't go. There's nothing I can multiply 15 by to get 100. So division again. I'm not afraid of division, are you? We're not afraid. Okay. I just did it again. Okay, 10 divided by 15 doesn't go. But here we do need to, let's skip count really quick. Okay, guys? 15, 30, 45, 60, 60, 70, 75, 75, 85, 90, 90. Oh, we don't need the next one. So 1, 2, 3, 4, 5, 6. 6 times 15 is 90. 100, take away 90 is 10. Bring down a 0. Oh, and we're back at 100. So there is our repeating decimal. You know, I wonder, we could have thought of it this way. If we divide this by, divide the top and bottom by 5, we get 2/3, and I bet that's on our chart, 2/3. Well, 1/3 is 2/3? Yes, 2/3 is as well. And that's, look at that, 0.6 repeating. Okay, so, but we've already figured that out now. So we have 0 and 6 repeating, 6/10 repeating. Oh, negative number, I'm going to put that there right away. And it's 4/5, so that is 4, I need some space, 4 divided by 5. Let's switch colors here. Okay, so let's make a decimal. Okay, so that's 5 into 40. Doesn't that go evenly? 5 times 8, yeah. So we're done, and it's terminating because that goes evenly. So that is negative, no holes, and 8/10. No bar, it didn't repeat, right? 8 times 5 is 40, subtract 0, we're done. Okay, oh, whole number, let's write it right away. And then we have 5/9, so let's do that work real quick. That would be 5 divided by 9. 9 does not go into 5. Let's switch colors here. So 9 goes into 50. Oh, that would be 5. Wait, what's 9 times 6? 9 times 6 is, oh, too much, 54. So 45, subtract 50 minus 45 is 5. Oh, didn't we start with a 5? What's going to happen here when I bring down the 0? We have found our repeating decimal. So 1 5/9 is 1.5 repeating. 1.5. But not true 1.5, because technically half of 9 is, well, half of 8 is 4, so that'd be 0.45, right? Okay, but when you round that,
Don't lose it.
when you round that, 5 is 5 or higher, so that would be 0.5 if you round to the tenths. Yeah, we're done there. Dana bought 2/3 yard of fabric to make a new purse. Write the amount of fabric she used as a decimal. 2/3 is a common fraction. Did you realize that? Let's go look at our chart. 2/3, there it is. 0.6 repeating. So let's put that down there.
That wasn't shut.
0, and that would be my fault. Oh, I'm talking to my mother. I didn't shut the fridge. Okay, how are repeating decimals used in real world situations?
Okay, come on.
That's my mom talking to her dog. Okay, so how are repeating decimals used in real world situations? Let's think about that. Well, numbers don't divide evenly, right? Okay, so what if I asked you in a recipe to have 0.3 repeating cups of sugar in the cookies. How would you know when to stop having sugar? That would be ridiculous, right? Okay, so, well, here's one. You boys, and maybe some of you girls will recognize this, batting averages. Okay, so we get an average by dividing, right? But we have to have an end to it. So repeating, it could end up in a repeating decimal. So we need to either round at some point or use bar notation to indicate that, because we can't spend all day talking about batting averages, right? All right, go practice some on your own. Don't be afraid of the division. You know it's going to end, either because it's a repeating decimal and you can stop, or it will just end. We're not afraid of division. We do it all the time. Ask for help if you need it.